Now, moving on to the main show, really, this is all about Pythagoras. Now, Pythagoras was a Greek man who discovered this mathematical principle. Now, there wouldn't have been any calculators back in them days or anything. It was all done by structures and things. Very clever man, Pythagoras, not just known for his maths. So, what we have here is a right-angled triangle. Now, I don't have to explain to you what a right-angled triangle is, but Pythagoras' theorem just applies to right-angled triangles, and it is a way of proving whether a triangle is right-angled, or it's using the fact that it's right-angled to work out some lengths. And what Pythagoras discovered was that if you make a square on each side, now remember a square has the same length as width, so this side originally was 3, so it's a 3 by 3 square I've put on here, and I put a 4 by 4 on here. What Pythagoras realised was that if you add the square area of this to the square area of this, you get the square area of the big side. We call this the hypotenuse. So Pythagoras realised that the sum of the square on this side and the square on this side will always equal the square on the longest side. So here we've got a 512 triangle. The area of this is going to be 25. The area of this is 144. If I add those two numbers together, that makes 169. I know the area of this big square here is clearly 169, the square root of which, hang on, go back a minute, sorry. The square root of which is 13, so it hasn't put that on there, but it tells me that the length here is going to be 13 centimetres, because 169 square rooted is 13. Here I've got an 8, 6, so 6 squared, 36, 8 squared, 64. I know that the area of this is going to be 100, and it probably won't give me the length again. I think that's the next bit, but the area is 100, and I know that the length is going to be 10. Okay, so the actual formula goes, the square on the hypotenuse, that's what this is called, is equal to the sum, which means add, the sum of the two squares on the other two sides. So you can imagine Pythagoras building and making big square planks on each of these sides. I'm sure he did it really. So 3, 4, 3 squared, 4 squared, 3 squared is 9, 4 squared is 16, and that's going to be 25. So the square on the hypotenuse of a right-angled triangle has the same area as the sum of the squares of the other two sides. Like that. Now, we are not going to spend our life, whenever we answer a question, drawing big squares. That would be just too time-consuming. That's the principle behind this whole method. We're just going to be using the numbers.